and viewer from good morning and good day to all audience and viewer from Masa University Facebook page and YouTube channel. Welcome to the webinar conducted by Faculty of Engineering, Built Environment and Information Technology of Masa University. My name is Danish and I'm an IT student in Masa University and I'll be serving as your moderator today. Today, we'll be hearing a presentation from IR Dr. Muhammad Arkam bin Che Munaim. IR Dr. Muhammad Arkam bin Che Munaim has obtained his PhD in Energy Conservation from the University Science Malaysia in Penang in the year of 2014. His PhD research focused on the fiber optic daylighting application for interior illumination under Malaysian skies. He is the recipient of Building Engineer of the Year 2022 awards by the Chartered Association Building Engineers, United Kingdom. IR Dr. Muhammad Arkam has also published papers in the area of energy conservation, especially in daylighting systems, solar energy, indoor thermal performance, and office indoor environmental quality (IEQ). Currently, he is the CEO of Mega Jati Academy and professional panel advisors to many universities. Without further ado, I would like to welcome IR Dr. Muhammad Arkam, who will be speaking to us with topic optimization of building energy performance through passive design strategies. All right, Dr. Muhammad Arkam, the floor is yours.
Thank you very much, Danish, as moderator today. Good evening, everyone, from everywhere. I'm actually Muhammad Arkam from currently from Singapore, Tani, Kedah. Regarding the topic today, optimization of building energy performance through passive design strategies. We have prepared some slide for your view, as mentioned by the moderator, and we'll try to elaborate the strategy as well as on how to optimize the building energy performance through passive design. As mentioned, I'm actually an industry from the university as well as the industry. We have conducted quite many, research as well as the exploration through building services as well as the energy and also green building. So as a part of my introduction today, welcome all for the session today. And let's start with some exploration of the keywords today. We are talking about passive design strategies. You go for our Google and check what is actually will pop up when we research for this keyword. Basically, they will explain us for some basic terms regarding passive design strategies, where it refers as a set of design approaches focused on utilizing the natural environment. So natural environment become the keywords for the overall passive design strategy, where we want to try to maximize and optimize the nearest environment outside the building to utilized by interior, either for cold or heat, or maybe from the light. So there is basic terms when we talk about passive design strategies. To provide heating, for some countries, we got that heat. Cooling for other countries, this is cooling, the four season, and also ventilation and lighting to the building. So this is what we're talking about passive design strategy. We go for Google translation or Google definition, but it's somehow there, basically somehow there. I like active design strategies that rely on mechanical systems. So the what we call it, opposition of passive design is actually the active design. So active design is talking about the mechanical system or processes that been imposed into the building to improve the optimization of the energy inside the building. So the keywords that we want to talk about today is about passive design strategies, and some of the pictures that we talked from our Google search or Google image. So on the right hand side. So I'll try to explain a little bit about passive design strategies for us to understand what is all about passive design strategy when talk about building construction or building services in our country and our climate especially. And we of course we talk about why first. Why we want to go for passive design strategies. So passive design or passive design buildings use strategies, lot of strategy there to maximize energy efficiency. So that is our main aim regarding passive design in terms of building to maintain the human comfort. So we'll talk about human comfort and how we want to use the nearest environment to the building to optimize the energy efficiency. So that is the basic things. The key to the strategy is to maximize the energy that is gained and minimize the energy that is lost. So we want to maximize whatever the useful energy from the immediate environment. So we talk about immediate environment, we know the building, we have the building envelope. Building envelope is actually the skin of the buildings. We talk about walls, we talk about roof, uh, walls and roof is considered as building envelope. So whatever outside the envelope, we consider as the nearest environment. That nearest environment sometimes, and most of the time actually, having a lot of opportunity for us to gain, to maximize whatever that can be beneficial for us inside the building. At the same time, we want to minimize to the loss. So bear in mind that in our climate in Malaysia or tropical climate, we are blessed with a lot of, sun radiation or solar radiation. We have been construct a building, considering the how the solar radiation and how the solar, illuminance to be very useful for us inside the building. So it can be also part of the consideration. And we are using the main reference here from the Malaysian standard MS 1525 2019, energy efficiency and use of renewable energy for the non-residential buildings, Code of Practice or third revision. So this remain our reference for today's webinar. And indoor environment. Uh, the human comfort, for instance, we talk two main terms here: energy efficiency and human comfort. So before we go for energy efficiency, we need to understand what is actually the human comfort, because human comfort is different based on the activities, based on the what we call that background of building, or what kind of building that we've constructed, or even in the climate is going to be different. So perceptions about the indoor environment is closely linked to health, well-being, and productivity. So human comfort perception about the indoor environment. So we talk about indoor and how the indoor environment can give us a comfort to become to be one of the occupants of the building. Improvement of the comfort level in the buildings, significant positive impacts to the occupants. Human comfort in indoor environment usually can be addressed in two: comfort, thermal comfort, and also visual comfort. So that is the main two environmental indoor comfort that we're looking for. In fact, it got many, about depend on the book. Some book tell four, some book tells five, some other book tells six. But I want to just to talk about these two: thermal comfort and also visual comforts. Thermal comfort means taking into account a range of environmental, work-related, and personal factors, deciding that makes a comfortable workplace temperature. Talking about temperature. Thermal comfort, generally talking about temperature. So my thermal comfort is different from other person thermal comfort. So we might having that kind of discrepancies between humans when talk about human comfort. So maybe I'm okay with 20, 22, 23 degrees C inside the building. Some other maybe they require lesser, or maybe 25, 27. So it's depend. But somehow in that book, this guideline of Malaysian standard, we have that standard. What is the human comfort compared that acceptable among humans, either for a ventilated area or non-ventilated area, air-conditioned area or non-air-conditioned area. So it's been researched and been tabulated the actual human comfort that we can go through. Other than that, is actually visual comfort, characterized as a sufficient amount of natural light, and of course the artificial light as well. Natural light is coming from the sun, artificial light is coming from our electrical appliances, electrical fittings such as lights and whatnot, lighting and whatnot. Good glare control, on how to control the glare inside the building, and access to the view of the outdoors. So our eyes also looking for the outdoor view. So this is actually basic human needs, where we want to have a location or position in our office or in our house that we can view outside environment. That is our visual comfort, or that's our basic needs as a human to understand what is the comfort means. So other than these two comfort, thermal comfort and visual comfort, I'm not going to talk today because we will drag our presentation. You can find it in other book, other references. We got 4 or 5 basic human comfort. But these two is very related to the book that we are going to explain today. So that is why I just choose these two only. Huh? But if you're looking into these two, thermal comfort and also visual comfort, it basically goes to one direction only. We talk about visual comfort comes from visual come from light come from the sun. Thermal comfort, talking about temperature. Temperature comes from solar radiation. Solar radiation comes from the sun. So basically, sun is the main factors here. When talking about this human comfort for indoor environment, sun is playing very important role for us to utilize whatever that useful outside environment, such as light, useful light, and maybe useful temperature to be bring in inside the building. Okay, this is quite complicated, but it's very true. We're talking about comfort zone for everybody, where we can have this kind of graph where we map everybody, everything. So, for example, number one, the comfort zone. There is actually our comfort zone when we're talking about acceptable level of comfort for the majority of the human being. So, for example, we're talking about humidity. We started from 20 up to maximum about 80. And then talking about what the temperature, dry bulb. Dry bulb is actually our ambient temperature. The minimum between 20, the maximum is actually about 24, 25. So there is a maximum. And we're talking about humidity. Yeah, wet bulb we don't talk much here lah. So dry bulb is actually our ambient temperature. So, and relative humidity, RH here, percentage is about 20 to 80, 20 to 80 or 60 or about close to 80. So that is where we derive the comfort zone. The comfort zone. Other than that is acceptable, permissible. Number two. Number three is heating internal gain. Means to say that we need to go for heating elements. We go for heater. This area, this zone. I'm not sure you can see my cursor or not, but number three there is talking about heating elements. You need to go for heating elements. Four, so the same thing. Passive solar heating, active solar heating. And number six is require the humidification, where the area is too wet. Too wet. And also talking about solar protection, when we talk about on the right side, number five, sorry, not number five, number eight is talking about the solar protection, where you need to go for tinted film and whatnot. Cooling high thermal mass, evaporative cooling, then we go for cooling, number 11 here. So that is where we can understand our building when we map everything, what is actually the active strategies that required for the building when talk about human comfort in terms of the temperature comfort or thermal comfort. So this chart is actually explaining or summarizing about the temperature in terms of the um, thermal comfort for the building. So, for example, the 14 there is talking about conventional dry. It's too wet there. It's too wet. So we need to go for some drier process to make our environment is back to number one. Back to number one. So other than number one is actually not so convenient for us to stay. We're talking about indoor where we position ourselves in indoor enclosure or indoor building. So other than number one is not I mean not advisable. It can lead to something else. For example, sick building syndrome. For example, what we call that um, uh, uh, insufficient of thermal, that we become somehow we become in uncomfortable with that kind of zone. So we're talking about zone one. That is the aim of every design or the building or any places that you want to go for number one in terms of the comfort zone and comfort level. So we've been researched by many scholars to come out with this chart to make us understand what is actually the comfort level that we are talking about when talk about thermal comfort. So let's talk about evaporative heat exchange, for example, direct evaporative cooling. So this is how we can do in terms to get the thermal comfort for natural ventilation. For example, this is a water pond over here, and we know the sun. I mean, the airflow we come in and go to the outside through the roof opening, and we can go also for vegetation coming from the opening from the bottom and going towards to the roof opening for the circulation for the air circulation. So this is one of the strategy where we're going to go for direct evaporative cooling, either using the pond or using the vegetation. It can be done for our building to filter up some what we call that to cool up some hot air before enter our building. Then we release it back through our roof monitor or roof opening, go back to the what we call the environment. So this is how it can be circulated inside our building using this concept. I mean, to improve the airflow or air exchange in our building. So other than that, we can have also the heat stored for some other countries where we got four seasons, for example. They can store the heat through the building material. For example, this floor storing the heat from the sun on the sunny days, and then on the night time, the heat will be released back from the materials, either floor or walls. So, but in our countries, this also happen. I mean, we store the heat inside our building, uh, and at the night time, our house become hotter due to heat release from the building material, either floor or walls. So it has also happened here. It's not supposed to be that way because we are in the hot and humid climate. Uh, but something need to be done to improve this in terms of maybe insulation, maybe passive design strategies to increase. To prevent the heat stored from our building materials, and we need to choose our building materials in the specification that not to contain or to absorb the heat to be released back during the night. Okay, this more complicated design where we can explain regarding the heat, the flow coming from the side of the building and then going back to the roof opening or roof monitor to create the internal circulation of the building, internal circulation, where we can go for passive cooling. So these strategies will help to less dependent on the passive strategies such as fan or air condition, where we can have a nice, flow from the hot air to the cool air and bring everything out of our building or our building envelope or our enclosure buildings to remove to release back to the air. So this can be done by using either direct cooling, the cross ventilation or stack ventilation. They can be shown later from that reference as well. So one of the advantage of having vegetation uh, at the right positioning, because we need to understand the sun path as well. So we'll talk about sun path later in this presentation also today. And later, other than what we call it thermal comfort, this is a visual comfort. This is a visual comfort where we can bounce light from the exterior coming to into our area, our working space, and we can get glare. So, for example, you can see this is shadow over here, and this fella is looking into the monitor with bright glare, bright high brightness coming from the window, and this another person is looking at the computer from the shadow under the shadow. So it create another, different perspective or different what we call that experience when you look into this kind of situation regarding the what you call that sun. The glare from the sun to enter the building. So these also need to be protected. You can go for example, tinted glass. Maybe you can go for another things, blind or whatever can minimize the impact of the solar glare. But you need some the I mean the useful light. So, for example, at my back here, also actually the window there, so it's quite bright in terms of my space. Working space is quite bright. I don't have to switch on my lamp to use the space over here. So what we need to do is actually to differentiate or um, just take the useful lights, because lights also comes with heat. So we need to understand how to remove the heat from the useful light so that the useful light will be here, the heat will be stay outside. We don't bring the heat come in. That can be done by a few passive building strategies as well. So this is direct glare, for example. Also, we got also need to be noticed what the reflected glare is also quite interrupting when we talk about work. It's quite interrupting where we have very high brightness, highly glare area, so it will be interrupting when we do our daily routine work, especially when we talk about computer. And then these are some the strategies. We have luminaire air and also the intensity coming from the luminaire, and also this one, I mean the left bottom here talking about the glare also coming from the sun, and also the reflected glare is coming from all fittings that we have in our our home and the working space. So quite also the artificial light also can create glares. So where we can have anti-glare fittings, or we can also have very good formation of lighting so that it won't affect our eyes when talk about working in the visual comfort. They want to want to go for visual comfort, either using this sun or using the artificial light. Okay, the book again. The recommendation for good practice in renewable energy application are classified under the following areas. So we want to maximize the passive solar design. So we want to design our building passively, maximize it. How we can do through this standard we can follow. Secondly, to optimize passive cooling strategies. So reverse of it. Solar design must be maximized, optimize the passive cooling strategies on how we want to cool our indoor environment by using less energy, especially from the electrical energy. Optimizing environmental cooling, such as vegetation, set planning, landscaping, and also shading. It can be done also by optimizing the cooling, environmental cooling from trees, vegetation, or how you want to plan your site, or you put a landscape or a shade. So this is all about the passive strategies. Where passive strategy in general doesn't need any mechanical or electrical effort to make it work. So it can become one of the strategies that we can implement from the beginning when we want to construct the building. Maximize the capture of renewable energy. So we don't want to talk about this renewable energy today, but there is the solar heating, solar electricity, solar lighting, and whatnot. So we are not going to talk about it because it become another topic for this webinar. Okay, then the requirement. Okay. Our energy efficiency classified under the following areas: design efficient lighting system. So this, when talk about artificial light, minimize loss in electrical power. We don't want to talk about that also. Design an efficient aircon and mechanical ventilation. It can be done. And design a good energy management system is also more complicated. We want to interact or integrate everything inside the building by using the energy management system. It's actually what we call that available in the market now. But it's more complicated for us. We want to talk just about the sustainable design approach today. So when we talk about architectural and passive design strategies, we want to design within the contextual climate. Contextual climate is refer to what is actually your position. We need to understand our position here in Malaysia, equatorial, Kuala Lumpur, for example. So we want to go for that contextual climate. It's very, specific area. And site is the first step to optimize the benefit. So first step, we need to understand our climate first, our own climate here in our location. So when we want to construct or we want to do our own space or buildings, so this become main important thing. Where is your contextual climate? Provided by the specific environment. Specific environment, in this case, we want to talk about, of course, vegetational areas. Lot of trees will become different. You want to build a house in the woods, it will be different. When you want to build a house in the, concrete woods, for example. So it become different. Design solutions shall strive to achieve energy efficiency, to use environmentally friendly materials of high quality and durability in order to decrease waste. Decrease waste in this context is decrease waste in terms of energy waste. Energy waste. Combine. So this is important. This second paragraph is important. Combine architectural, engineering, site planning, and landscape. as a holistic approach to design energy efficient EE building will optimize the energy efficient building, especially when employ combined passive and active devices. So after all, we still need to use the active devices. We cannot rely 100% on combined passive strategies, where the active also need to be introduced inside the building. So on overall, that is where we go for holistic approaches, where we take care of everything, understand the specific environment, contextual climate. At the same time, we go for combination of these architectural, engineering, set planning, landscaping, vegetation, hardscape, landscape, softscape, and all those combined and become our passive building. Later on, we add on minimum active devices just to make sure the building is working properly under, the control. The specific passive design strategies. So it can be done by using understanding the combination of those to to be adopted in our project or our building. Okay, this is too long. I'll go straight to the point A to G there. Huh? Architectural passive design consideration, we need to consider following. The first one, the site planning and orientation. How we want to plan the position of our building, if possible. If possible, you want to construct a new building, of course, you have that luxury. If the existing building, you cannot do any other orientation, is actually fixed there. But something that can be improved or can be adopted. Daylighting, facade design, natural ventilation, thermal insulation, strategic landscape, and RE, renewable energy, if possible. But again, I will not talk about the RE now. These factors are just important, the selection of active system of devices. So we want to select the active system of devices to control visual and thermal comfort just now we're talking about, and need to impose any significant cost compared to more highly serviced buildings. So A to F is very important for passive design. Now we talk about set planning up to the strategic landscaping just now. Okay, this one is very, very important. Sun path in our area. Latitude 3.2 degree north, longitude 101.7 degree east. So this is actually the sun path where the sun is actually um, from where is east. This one is so north, east, west, and also south. So coming from 1st June, for example, 1st June, it starts from June, go to this area, and then July, up to July, and then it come back. Oh, sorry. Start from January. Sorry, it's January. Yeah, January, February, March, April, May, June, July, going to this direction. July, August, September, October, November, December. So our sun is actually not coming from the exact same point every day. We need to know this very, very well. That's why our shadow is different based on the sun positioning, and the sun positioning is fixed uh, through this kind of the path. So coming from, for example, January here, go to here. This is the way. Can you see my cursor, Danish? You can see my cursor, huh?
Sir, I cannot see your cursor, sir.
Cannot see cursor, huh? So just
Hmm.
the bottom one, the January one. I'm not sure how to help you on this. Let me see. Is there any? No, I don't. How to put my cursor there? I cannot cursor. Just to this January, 1st January in the bottom right there. Huh? Bottom
Okay,
right there.
sir.
January,
January, yeah.
February, March, April, May, June, and left top left here, July, August, September,
July,
October,
August.
November, December. Yeah, you can see that.
Yeah,
So
that one I can
basically,
see,
this
sir.
is
Yeah.
okay. This is actually where our sun is actually. Oh yeah, I got something to show you. This is my topic. So I got my globe in my house, in my office. Okay, here. So the sun positioning actually not here. Okay, something like coming from here, and then it come a bit, little bit up, and coming back, coming back. So then they come below again, up and down. So it actually happen in our climate, in tropical climate. So we are in the equator, so that our sun is just top of our sky, and just top of our sky. So that is where we can find our equinox every time, 2 times per year. So that is where we can find equinox, where the sun is precisely on top here. Center of the cross. You can see cross from that globe. So the cross will be our exact point where the equinox happened, and the equinox happened last month. So that is why we are. We are on our, yeah, we're talking about apa, stroke harbor, heat stroke, last few days, and there is no more heat stroke coming because the season is over now. The season is over now. He come back somewhere in September. So there is no point to talk about heat stroke anymore, basically, because it's past, overriding by event. But it's very important to understand about how it can, I mean, effect to our lifestyle as well. So this is actually the sun positioning. So we talk about Earth like this. The sun is actually coming here. We're talking about this right side, from the east, coming up and down, up and down, up and down. So this is the first thing. But I got more interesting pictures to show you where the pictures on the left is actually the location of the sun every month from December. Sorry, talk about January lah. January, December. The most right here, I mean on the January, December, you can see the arrow there. I put my marker there. And again December for the next year. Right? December 2022, for example, December 2023, complete 1 year. So other than that, the sun is actually moving. It's not coming straight from the same area every day. No, no. Actually coming from different, but very, we don't notice it. We don't notice. Except if you go for, if you like this topic, you will be somehow notice lah. But you don't care. We don't notice actually. It's actually a day, a blessed day, for us to get every day sun. Up to now lah, we don't have that. For and the top right there, we have January. Sorry, not January, June, where the sun is positioning far to the east north. Huh? Northeast. So yang ni far to the southeast. Southeast and northeast. Southeast and northeast. So all east lah, but north or south only. So this is how the positioning of the sun been created by our creator. And the basic design strategy, again, talking about the good ventilation, where you know the sun movement, in terms of this, actually you know how to utilize the sun positioning in terms to get the utilizing of your building requirement. So I want to go fast for you, just about 17 slides just now. And here again, we're talking about how the sun orbit, how the earth is actually orbiting the sun. So this is where the sun and earth position closest and farthest. 147 million kilometers is the closest. 152 kilometers is the most far. Sun, I mean the position of sun against the earth. So understanding against equinox March, we just left in 21st of March. Just 21st of March, and September will be coming about 23rd of September. So that is where the heat stroke hazard is occur due to this equinox, but no more. The threat is no more due to the overridden by the event. Okay, so we talk about local Malaysia. This is our sun pass. But when I understand it, we want to go for other countries. For example, New Zealand over here, the sun pass is different. The sun pass is the north side. They can see the sun on the north side. Meanwhile, in the UK, we can see the sun on the south side. So we don't have this kind of above of our position. So that is why in the north hemisphere in the UK, Europe, all solar panel facing 60 degree to the south. And that is most common reference that we have in the book before we started our own project on solar power plant. 60 degree to the south, because we are referring to the UK. They're actually facing to the south because the sun is actually positioned to the south. In the southern hemisphere, for example, in New Zealand, the sun is positioned on the north, so they're facing 60 degree to the north. In our climate, so basically we can have about flat or slightly slanting into south, much better, due to the coverage of the south is greater than coverage to the north. This is coverage to the north, from equatorial to the north. and equatorial to the south is more space for us. So that is why we set at 20 to 25 degree of our solar panel facing to the south, because the south is more I mean the position of light of the position of sun is more precise there in terms of our where we do our research. So there is how actually the positioning of the sun inside. So understand that, then only we can do this kind of basic concept on where we want to position on our facility or building or house or whatnot or project, how we want to position it due to this kind of situation. This is summer and winter, we don't have that in our climate, but by understand the concept is there. So understanding the concept is more important, because if you know the concept of positioning your building to maximize the sun uh, energy from you, either you get from the solar, either to get to from the lights. So it's more appropriate for you to put it your design according to the position of the building, where you want to construct so this is the fundamental concept where we want to go for when we talk about site planning and also building orientation. So this is much related. When we understand this, we can go for our own positioning or building orientation based on the actual sign position is more beneficial for our building to get optimizing from the sun powers lah, sun powers. Okay, beside the sun or beside the we talk about sun, we got about two things. First one is with the heat. Second one is actually the intensity of the lights. The intensity of the lights translate into the lux level, illuminance level that we can have the visual comfort. And heat is actually go for the thermal comfort, where we can get the temperature, or temperature up or down is actually the same terms, temperature also lah, either heat, either high or low. So with that, understanding the the heat in terms of power coming from the sun, then we can understand what about wind. Wind also move or flow according to the this kind of concept coming from the sun as well, because some places are hot, some places are cold, so the wind is actually flowing into this direction that we can cap lah, that we can understand. So in our equatorial line, zero here, the wind coming from a lot of directions. It's unpredictable. It's actually coming from multiple directions. So that is why our wind turbine is not so working in our climate. It's not working uh, in our climate. So we are more into the solar panel or other than renewable energy. So because you can see the arrows showing where is actually the wind coming. We can come from the south as well coming from the north. So we actually the middle everywhere is going for this. Multiple directions. So we cannot get a very constant wind coming from the one direction. So that is why that wind turbine is uh, more beneficial for countries for the top hemisphere or the north hemisphere, such as in the UK there, German, or even France there, because they have nice flow, continuous, consistent, and one direction. One direction of wind flowing. Because it's very important to design the wind turbine according to the wind direction. We can do that. We cannot do this in our climate. Because we can get wind from either south or even north. So that is why we are actually in the middle. Don't have that luxury to use or to tap the wind energy to become our source of energy. Even though we are so keen to do so lah. And understanding the wind direction, then you can stack. You can put your building accordingly to the position where the wind should flow, the wind direction. We can understand the wind direction if we get this kind of luxury when in terms of the wind, flow in the world. Global wind flow, but we cannot get it. So the best that we know lah, the best that we know, wind direction should be here. Then we try to understand some local contextual climate there, where we can go for a directional wind, so that we can have our building coming from one opening and going out from another opening. This is for cross ventilation, and one more is actually the stack ventilation coming from the bottom and going up and release to the environment, to the second outlet is the same in the building. So this is the Bernoulli concept or the Bernoulli principle is here, the hydraulic is here, as well as the heat transfer. You want to talk about the engineering basic or engineering fundamental here is a lot of things to be discussed, but we want to touch that because we just use the building science to understand how we can position our building according to the right positioning where we want to go for our construction. Okay, air movement. I think I need to skip there. It's just telling about airspeed 0.25 and below. This is how the sensation that we can get up to 1.5 and above. So what is actually the position? So this is how to understand the air movement so that we can position our opening right precisely on the area that we want it to be function. We want it to be function, or else it won't function. You will put something uh, devices or passive device a passive strategy, but it won't function in our climate due to this misunderstanding of the effect of the mechanical effect due to the wind movement. Okay, again, I think the same concept before previous pictures also showing the same thing lah. We have the planting or we have the vegetation coming from the pond or landscape garden, and then go inside the building to get a very cold breezing, and then coming out through the hotter air. So that is where the wind will be flow from one point to another, coming through our house or our building, just to get the airflow constantly to improve our thermal comfort. Okay, knowing of the direction of wind circulation, direct the sun path at specific location, then we remind it, design within the contextual climate. And site is the first step to optimize the benefit of providing the specific environment. So the combined architecture, engineering, site planning, and landscaping would optimize the EE in the building, combine passive and active devices, then it's actually the sustainable design. Sustainable design approach where you put these combined passive and active devices into the building, where you understand everything about the environmental impact of your building, and then coming back to your passive devices to add in together, then they will be, I mean, functional as one teamwork for them between passive and active design strategies. So we put the passive design strategy plus active devices, then sustainable building will be there, will be surface there due to these strategies. Okay, some of the strategies we use the light shelf or skylight, but be careful. By using skylight, basically you also invite the heat to come in. So there must be a strategy how to remove the unwanted heat from the lights, from the useful lights. So it's very a lot of strategy that can be imposed. One of it we can put two layers. Glass, and you can also put a glazer to no glazer. I mean the reflector, just to minimize the impact of direct skylight. But it can be designed, it can be done. Light well, sawtooth roof. This is not important, not popular in our climate because it's facing to the one direction. It's basically in the north hemisphere. We're facing to the south, and the south hemisphere we're facing to the north. Regarding that sun path that we have been talking just now, light well is also one of the approach. Roof monitor is very popular here in Malaysia. Atrium also very popular here in Malaysia. So just to understand where the positioning of the sun and where to put our atrium to optimize the power, the light illuminance from the sun to be useful in the indoor building. So it can be designed, it can be simulated as well. It can be done in terms of a lot of materials being available now for you to choose your sustainable design approach. This is quite common. We can see on the light tube, for example, coming from the top and straight away to the interior of the building by using that aluminum reflectors inside. This is where the tube coming or collecting the lights from the sun, pushing towards the diffuser inside the building with some limitation as well. But it's also workable in some areas. This is how solar tube is working. From the top, getting the solar, and then the sun, the light is really bounced inside this aluminum reflector and coming out from the sky directly from the sky. This is to illuminate the area where you don't require to open up or to switch on your artificial lights. So it can be useful when we talk about passive design or passive lighting system. This is more complex. solar lighting on the Himawari regarding the solar, I mean, fiber optic daylighting. This is the grid integrated efficient building where we can put everything in our building. Start from the solar storage there, lighting controls, window shading, window efficient and wall, efficient window and walls, EV charging for the car transportation, building energy management system, hatchback zoning control, energy information, kan, smart meter, utility power thermostat, smart thermostat to control our internal temperature, and plug load control is also can be done. This is part of the active devices that we can put or implement or impose in our building beside this passive that have been discussed before. So these all the passive, the active devices, except for this efficient window and walls lah. Other than that, is all active. Okay, 45 minutes. The purpose of this Malaysian standards to encourage the design, construction, operation, and maintenance of new and existing building in a manner to reduce energy without constraining creativity. We want to have a very nice building, workable, functional. We don't constrain the creativity of the owner or the designer or the engineers or the architects to express their creativity in design, building function, the comfort of productivity of the occupants, appropriately dealing with the cost consideration. We need to understand the cost as well, cost impact due to the design, and provide the criteria and minimum standards for energy efficiency in the design of new building, retrofit, or existing building. Methods of determining compliance with these criteria and minimum standards. So the standard is actually designed for this purpose. Provide guidance for EE designs to demonstrate good professional judgment to comply with minimum standard and encourage the application of RE in the new building or the retrofit or new buildings. So I think that for 45 minutes. Danish, is there anything to add on?
Yes, sir. For now,
Yeah.
no, nothing to add on.
Okay, thank you. There is my email there and also my phone number there. So basically, the slide also been shared to your lecturer just now, I think. So it can be downloaded and can be used for your reading. So this is what we can share on the passive design strategies regarding the building energy efficient optimization through passive design strategies. Back to you, Danish.
Thank you, IR, for sharing. But sir, I have one question regarding on the solar energy. Yeah, sir.
Yep, yep, please.
Oh yeah. Let's say we are building a building, right? Let's can we depend on solar energy for that building without any outsource like for electrical and energy consumption? Can we just depend on solar energy?
Maybe you try to talk about net zero energy, net zero
Yeah.
building. A net
Yes.
zero building is considered as a building where doesn't require any electrical
Yes.
supplies
Yes, sir.
for them to function. Uh, Actually, there was a research on this kind of topic. In fact, the actual building also been developed for showcase. It can be not straight away to the net zero, but highly efficient buildings. When we talk about highly efficient buildings, there has a parameters to show in terms of per person per meter square, per person per meter square, and actually how much the building uh, uh, use the energy for each person for each meter square. Up to that, we name it as a building energy index. So to get the net zero building, just to get it from the solar alone, most of the building is not possible. Most of the building is not possible, but there is some exclusion for some showcase building where we want to just to show that we can do something like this. We optimizing the solar power just to power up our building. It can be in a small scale, but not I mean not proven in terms of to get 100% from the solar itself. Is not proven. It can be done in terms of concepts and also in terms of the showcase, but for the long run, usually they will go back to the electrical power lah. But
Okay, sir.
it's a very good intention to design or to construct our building close to the net zero. You can get about, let's say, 60 to 70% uh, saving from the same comparatively building in terms of the same building. Of course, you want to compare, you use the same building to compare each other. So office building, manufacturing building, hotel and resort. So there is what is actually categorized under the GBI, of course, or manufacturing building or office, normal office building. So the category is there already. Only what is the building energy index level from each category is different based on the uh, functional of the building. So to get close to the net zero building is quite impossible. We still need the electrical energy to be fit in, just to power up the building, to get our services run. Right?
Okay, sir. Thank you for the
It's a
clear
good concept.
explanation.
It's a good concept. You can refer back. I mean, a lot of reference coming from the GBI Malaysia, GBIM, and from that categorization of the building, new industrial building, residential, manufacturing, townhouse, hotel, resort. So everything is there. The indicator is there. How we want to communicate with that kind of tools, for that we can come up with our own close to net zero building if it's very desirable.
Thank you for the clear explanation, sir. We have came to the end of the
Okay,
part of the presentation. Thank you, Dr. Muhammad Arkam, for addressing the is interesting topic and for this sharing session. Hopefully, this presentation was beneficial for everyone. On behalf of Masa University, we would like to thank you for joining us today. Thank you for your time and cooperation, sir.
thank you.
Thank you, sir.